Hey everybody, this is Larry, this is me going Q3 of the bi-weekly contest 138, find the count of good integers. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, I took 36 minutes, but honestly, I misread this one. If you watched the live portion of it, I actually solved another difficult dynamic programming problem, which, I don't know, I think that actually would have made a very good problem, and good enough that I tried to solve it, and it was a good hard problem, but nonetheless, that is not the problem. What I did was that, in case you're wondering, I mean, it's only like, I'll talk about it for another 20 seconds. But yeah, the way that I solved it, I thought that how did I think about this? I thought that it has to be divisible by k after the rearrangement, not before. So that's basically, so that subtle difference is all the difference, because for example, in this case, if you have, I guess 101, if I have 110 is divisible by 5, and it can be rearranged in the palindrome, which is 101, but yeah, I did it in the wrong order, basically, in understanding it. So I spent about half an hour, or maybe 20 minutes, maybe not that long, fixing this. So if you watch the live portion, you could skip ahead, or maybe you see my thought process about that problem, and until I finally figured that I was reading the wrong thing. So what about this one, right? So this one, well, you know that it's going to be palindrome, and the first thing to look at is constraints, and this one is n is equal to 10. I think we had a problem recently about this, or like a very similar hard problem about palindromes and stuff like that. So in that sense, it was already in my mind how to do it. But given n is equal to 10, that means that if you only care about, because it has to be a palindrome, you only care about, say, one half of it. Either the left half or the right half. Yeah, either the left half or the right half. It actually, I mean, maybe it matters. It doesn't matter that much, because it still matters. But there's only 5 digits, right? So if you have a 10-digit number, you only have 5 digits on the left half, and then just refract it on the right half, right? And because there are 5 digits on half the thing, that means that there's only 100,000 numbers. Less than that, actually, because it has to be exactly 5 digits, right? So it's actually this minus another 10,000, because you don't care about numbers that are smaller than that. So it's like, 90,000, which is, I mean, it doesn't matter that much, but it's still good, right? So that means that, did I do this wrong? 5 digits? Yeah, no, no, this is right. Yeah, okay. Yeah, 10,000 and 100,000. Yeah, right? So there's only 90,000 on half, right? So then now, if we're able to do math relatively cheaply, then we should be good. And that's basically the idea here that I end up doing, is that I just construct half of this, and yeah. And then I have all these things, right? And we'll work through some optimizations afterwards. But yeah, the first thing I did was I didn't want to think about n is equal to 1, to be honest. So I just did an n is equal to 1 special case. Probably you could have came up with it, but like in the rest of the code, but it's fine. So then now I just took the size of the left half, round up, but then -1 to make sure that we're on the counting is right. I mean, if you do the math, and then we have factorial. So here it is kind of very brute force. So now I for every possible n-digit numbers, or n over 2 numbers, right? So the half, I construct the actual number depending on whether it's odd or even. So if it's even, you don't have a middle digit. If it's odd, we chop off the middle digit and keep going, right? And one optimization you can do is that this operates every operation, so you can maybe take it out. It's not a big deal though. But yeah, and then here if the new number that we constructed is not, k is not equal to 0, then we can just continue. There are actually probably cleaner ways to do this, honestly, but we don't need to because, yeah. Because even if you do something really, really smart, it was only going to be 10 times faster, right? Because every 9 numbers is going to be divisible by whatever, by 9. So that means that at best you're 10 times faster, which is maybe helpful, but in this case, not necessary. So anyway, so we just convert it to thing. Keeping in mind that string operations in Python is relatively cheap, so it's a little bit of a nuance, and even converting to int is pretty cheap. I mean, this is only at most 10 digits, right? So it's not a big conversion. And this thing, yeah. And then next we, I guess this, I didn't need to convert to string. I think I just, because before I implemented it differently. But yeah, now after that, it is just maths. Okay, so here we go. Okay, so then now we construct a number, right? So let's say we have, I don't know, let's say k is equal to 1, so everything mods, right? So now we have this number, right? So let's say this is the left half. Oops. So then the right half is going to be this, right? So we have it in one number. So the way that I did it is I calculated how many ways are there for numbers to turn into this number, right? And that becomes a basic mathematical problem. How many ways are there to turn into this number? Well, honestly, I'm not going to go over this that much just because it is way basic combinatorics and just counting principles and stuff like that. Counting one-on-one. Maybe someday I'll do a thing on it, but this is way like, you know, entry-level combinatorics. And that's the part that is a prerequisite for this problem. If you don't know this stuff, I don't know that you need to know it for interviews, honestly, but if you don't know it, you're not going to solve this problem, right? That's just maybe the way it is. And the idea here is that it's just n factorial, in this case 10 factorial, over, pretend that's an over thing, over a sub 0 factorial, a sub 1 factorial, a sub 2 factorial, ... right? Multiply, just in case you... and that's basically... like you could say it in English in that n factorial is the number of combination, permutations of all the things, and then all the duplicates is that, okay, well, in one instance, let's say we have 2 2s, then there are 2 ways that they're interchangeable, right? So that's basically the idea. I mean, it's not a hard proof. There's a lot of counting 101 stuff here, but that's the idea. So that's the thing that you have to implement for one use case, right? Or one possible thing. So that's basically what I did here, is that I put them in a frequency table. So for each digit, I count the number of things that they show up. But one thing that I do, and we'll talk about this, why this is necessary later, but let's figure out this part first. So the thing is that, okay, so then this is the part where we do the n factorial over all the components factorial, right? So then now, so this is, for this one, right? And then now, what if you have a number that's like, okay, well, let's just add a 0 here, right? So then now in reverse, it's going to be 5 3 1, I don't know. I mean, yeah, it's this number, right? So again, you're going to do this n factorial thing on every one of the digits. And actually, let's just put another dupe in here so that it's a little bit, so then this will be 4 factorial because we have 4 3s and so forth, right? Yeah. So we have 10 factorial over 4 factorial for the number of 3s, 2 factorial for the number of 1s, 2 factorial for the number of 0s, and a 2 factorial for the number of 4s. But the problem is that, and that just means that you can construct other numbers, right? Meaning you could even have a 3 3 3 3, 1 1 0 0 4 4, and that would rearrange into this number, which is divisible by whatever we care about, right? Let's say that this is good, and it is, right? But the problem is that we have this leading 0 thing, right? So how do we get rid of the leading 0? Well, to get rid of the leading 0, we just put a 0 here, right? On the first item. And then now, everything, all the other digits cannot be ratted. So that's basically the idea, is that then now you count this. How many ways are there to count a leading 0. So then you just take the total number subtracted by 1 with 1 leading 0, right? And that's basically all there is to it. And the way that you do this is same as the counting 101 principle, which is in this case it's going to be n minus 1 factorial, because we have, well, one fewer number, because we fixed the first digit to be 0. And then it's the same thing here, except for that, well, we have one fewer 0, so then whatever, so a or counts of 0 is going to be minus 1, but everything else is straightforward. And of course we only do that if we have at least 1 0, and that's basically what I have here, right? If we have at least 1 0, we have n minus 1 factorial, we subtract the 0 because this is the thing. And then actually I had this incorrectly before. I had a typo during the contest where I divided by x instead of factorial x, so I had it divisible by divisible by 0 error. But yeah, so that wasn't even necessary anymore. But yeah, because 0 factorial is 1, so it shouldn't change anything. But yeah, so that's basically here, getting rid of combinations where we have leading zeros, right? And then here is just get all combinations. So the thing that is tricky and why we need this though is because, well, what if a number has multiple ways of being able to mod it, right? So maybe you have something like, I don't know, let's say let's say k is equal to 5. You have and n is equal to 5, so you have 5 digits. So maybe you do right, and 5 to 5 to 5, and then later, so your left half is going to look like this, your left half is going to look like this, right? Say. So then we count the number of things that this counts, and then count the number of things that this count, but of course they're duplicate, right? Oh wait, actually I lied on this one. This one is actually not. Okay, so sorry, give me a sec. So maybe something like this, right? So okay, so here you can see that these are duplicates because they both have 3 5s and 2 2s, but oh, this one is not good either. Okay, fine. I think if you add a 5, it should be okay. Yeah, maybe that was it. Okay, fine. Right? Something like this. Yeah. So then here, yeah, they're divisible. They're both divisible by 5. The left half looks like this for here. The right half looks like, or the left half looks like this for here, right? But you know that you're double counting because they both have 5 5s. Yeah, 5 5s and 2 2s, right? So that's basically why I have this thing, is that I created a normalized version of the input, and then if we've already seen this normalized version, then we just skip it. And again, the reason why this is fast enough is because we only have 100,000 numbers, right? So this is very fast. Sorting is very fast, and creating a string from a join is very fast, and yeah, and this is a relatively cheap operation. So yeah, that's basically the entire thing. So yeah, let's go. I mean, I know that I stopped to kind of go over the math here and there, but so let's go over the code all together, all at once. Right, so here I skip n is equal to 1 just because I didn't want to deal with it. This is the left half that we brute force on. The factorial is just n factorial. It goes up to n, and n is the number of digits, of course. So yeah, so then now here we construct the number, like the full number from the left half, right? Make sure it is k modded or whatever it's called. Get the frequency table of the digits. Make sure we haven't done this frequency table before yet, because we would have already double counted. And then here we just get all combination and get rid of combinations where leading to 0. And that's pretty much it. So what's the complexity here? It is exponential because n is the size of the it is very exponential, right? But another way of saying it though, it's going to be at most 100,000 numbers, and each number we do 10, like this costs 10, right, in the number of digits. So so it's gonna be like a million. This is O of 10, O of 10-ish. Sorting, I know it's 10 log 10, but O of 10-ish, right? This is O of 10-ish. This is O of 10-ish. So everything here is very cheap. So it's on the order of about, like, I want to say a million times whatever. So that's why this is fast enough. And a lot of the times, like these operations are cheap and this is cheap. So that's why we don't worry about it so much, right? Because this is cheap, then we don't do this most of the times, right? Like if k is 2, then we only do this half the time. So yeah, so very easy to do, or very cheap. The worst case is actually k is equal to 1, because then we do this every time, kind of. But we also get rid of a lot of the dupes, right? So we don't even do this part that much. I don't know that this. Oh yeah, it's necessary for double counting. It's not even like a memorization thing, right? So yeah. That's all I have for this one. Let me know what you think. Yeah, you could watch me try to solve the other variation on dynamic programming. I think it's actually a good problem. Maybe they'll even have it in the future. I don't know. But I mean, it's not that bad. I think the other problem is actually also interesting. So definitely give that a look. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve it live during the contest now. Today I am a slowpoke. Alright, now the actual contest begins with 7.3. Alright, let's take a look at this one first. I just wanted to see how many people can I give it a try. 2 positive integers n and k. X is k, x is a palindrome. X is divisible by k. Okay. What is the output? K is... Okay. If k is equal to 2, what is k? Oh. Divisible by whatever. Return the count of good integers containing n digits. And n can be... Oh, n can be 10. Huh. I mean, that's not as... K is divisible, okay. An integer is good if it can be rearranged. Oh, okay, let me think about it. That means we want, and it's n digits. If n is odd, then we just take everything, right? Divisible by 6. Bit mask dynamic programming sounds right, yeah. Okay. No one's gotten it yet? I'm surprised a little bit. Yeah, maybe not that. I mean, people maybe just whatever. Okay. Okay. If n mod 2 is equal to how do I do a bit count? Oh, it's a power of 2. Okay, so we could do that. And so it's left is equal to 0. So if n mod 2 is equal to 0 and used is equal to 0, then we return 1. If n mod 2 is equal to 1 and used is a power of 2, so something like this, right? Okay. And then now we just do one index at a time, shift and add. So the first digit cannot be 0. That's about it, right? So if from 0 to 10, if index is equal to 0 and I is equal to 0, we continue. Otherwise, we go index plus 1. Used flip 1 to I, and left is left times 10 plus I mod k. Right, something like this. This is wrong though, but it's a good a try. Good a try. Why is this wrong? Am I overcounting or undercounting? Okay, so this one's right, which is good. Okay, I mean, yeah, that should be right. I'm overcounting. Alright, let's try. What do I know the answer to? Say 2, 1. It's just every 2-digit numbers. That sounds right. Okay, so this is not useful. 3, 5. Two people died. I thought this would be right, but 3 is odd. Alright, all this looks right, so I'm not doing anything too funky. Left is equal to 0. Okay. What am I doing wrong? 3 digits. 5. Alright, let's do 3, 1. What does that mean? Is that even right? I don't know. What part is I don't know what the right answer is. I'm overcounting on the zeros because 110 is still no good. So how do I get rid of the leading zeros? Okay, so there's no leading 0, but then what about afterwards? Because we cannot do 110. Right? Or 100 is not right, right? So 100 is not right, and that is definitely one of the possible things. 100. How do I handle the 0 case? How do I handle the 0 case? Okay, so let's say we just ignore 0. We should be undercounting. Yep. So then now it's 25. So that means that we are only adding the 2 0 cases. What are the 0 cases? So it's 505 and 550, right? So those are the 2 0 cases. So I have to figure out how to So what are the impossible cases? That's what we're trying to figure out. Impossible cases are, in this case, 100, what, 200. So what is it about it that if half the number is 0, then you're forced to put it in the front? If half the number is 0, we'll put one number in the front or more. So if it's 1100, no, half is good. More than half means that we're forced to. Okay. What is that? 10 times 2 times 10 is 10,000 times, okay, 20,000, so zeros should be good. Okay, and otherwise, I guess we just skip it. Okay, we do this, and then we just handle if index is greater than 0. One used just to keep it consistent, right? Except for add zeros. So this is zeros. This is zeros plus 1. Okay, and then also if zeros is greater than n, we return 0, something like that. Okay, that's still wrong. Why? Left times 10, use Oh, I have to do it here too. I think I messed that up. Yeah, okay, fine, we do it here. Okay, we remove some for sure, but not enough, or maybe too many actually. No, okay, so that's not even it, right? Is it? Okay, so for 3 digits that's true, but without 5 digits, we have 11000, that's good. So all we need is 2 digits that are non-zeros to be the wrapper. 2 digits that are non-zero, okay. Or others maybe? Others plus 1. If others is greater than 2, then others is equal to 2, just so that we minimize the search space a little bit. Okay, we fixed the 3 and 5. Oh wait, no we didn't. Oh, because we didn't check for this, Larry. Okay, okay, so then now, if others, but then now we've messed up 1 digit, but that's okay. If others is greater than or equal to 2, that means that we have things, right? So that's good. So if it's less than or less than 2, then we return 0 unless it is 1. Right? If n is greater than or equal to 2 and others is less than 2, then okay. Got rid of some of the inputs, but that's not quite right, is it? You still have too many cases. Why? Others plus 1. This is hot and more annoying than I thought handle the thing, honestly. But what am I? Okay, so we have other digits that are non-zero. don't know if that helps, honestly, but oh, well, it doesn't because we want this to show here. So we have other stuff, right? We don't even care about the n is equal to 1 case yet. What the hell is this 27? So we have the middle digit can be 0, so that's what this is. And other digits are 2, right? So that's good. How did I get 35 from this though? What is the thing with the zeros? It's 2 or greater, right? Yeah, so what am I not blocking out here? This is 0, this is... Okay. Let's try this just to see that we have the same answer. Okay, so 25, this is still right with the 25. It means that there are no zeros. Though this is kind of weird, actually, but... So no zeros is 25 is still right. Right? So if others is less than n, right? Others is less than or equal to 1. If we have 2, then that means that others is 0. Why doesn't this filter out stuff? Like, how come this doesn't do anything? And also, how come this is undercounting now? Because of this thing, maybe? Am I doing this thing wrong? This one's overcounting, but this one's undercounting, which is actually surprising. Did I do this wrong? I can't even get this to overcount. Was this wrong before? I don't know why I'm struggling this one, honestly. Well, I don't know why, but I don't know why this is so wrong. I'm trying to get to overcount and still not overcounting. This is good though, I guess. Alright, let's focus on this for now and then we'll figure it out with the 5 case. I guess the even number cases are easier, maybe. I don't know, that's true. Maybe I should have... How many people got in this one? 70 people got in Q4, so I should have maybe done that one first. That's a little bit late. I feel like I'm close on this one though, so I have to get both to do a good score. But why? Oh, well, at least this is good, but that's because of this thing. So non-zero. How? So that means that we have 9. What does others mean? Oh, that means it's just that everything is not 0. So okay, I guess that's fine. But we need... Did I just messed up? Is it just this? No, because then now others have to be equal to 3. So okay. I think it's this, but I don't know why it's still overcounting. A cheating thing, whatever. I guess just all done. I guess it's just here. I think this should print a lot of stuff, hopefully. Okay. So this is good, this is good. Okay, so it's 35. What am I missing? Why is it only 27? Then. Okay. Am I missing some principle here? 110, that's good. Oh, it converts to 101, which is no good. No, wait. Are we? I think I misread this one. Integer is good if its digits can be arranged in the K palindrome. Okay, so after arrangement, it has to be able to. Okay, I misread this one. After rearranging, you're supposed to be modded, not before arranging. I see. So that means that this is not good. Okay, I misread this one altogether. Okay, so then how do I fix this? I don't know if I could fix this like this. Anyway, okay, and that explains why the other is undercounting a little bit. I mean, just because this is so raw. Okay. Okay, then now this is the question is how many. Okay, so this is the so after arranging has to be mod K. I mean, it's just brute force kind of, but I'm trying to think about the zero cases as well. I think that's the hard part still. So you have to say 101, which is trivial to do, or even 505, which is trivial to do. Then now you have to count, and the count is going to be. I think this is kind of. They actually do show you, but I just kind of okay. Okay, so then now you have to count the number of ways that. Okay, it's actually not that bad. Okay, fine. I just misread this one altogether. Okay, fine. It's annoying to write though, to fix rather. Okay, what am I doing? Just do half of the digits, right? So. I mean, it's so silly because this is exactly the problem that we had the other day, so that's why it's a little bit weird. Right. So then now we have yeah, this is just exactly silly, right? So okay, that means that it goes up to 10. We don't even need dynamic programming, right? So it's just 10 to the power of this, which is up to a million or something, right? So maybe that is a little bit sloppy. Or no, 100,000. What am I talking about? Right. If it is odd, then we round up. Okay, and then now we have total is I misread this one so hard. Okay, so current is equal to I plus reverse I, right? If n mod 2 is equal to 0, then this is true, else current is equal to I plus, we skip the first one, or maybe just divided by 10, I guess. Right. I spent half an hour on the wrong problem. This is unfortunate. Hopefully this is fast enough, because we do a lot of these operations. Okay, so then now we have all these things. That is definitely not right. Oh no, this is right, it's just that it has leading zeros. Okay. So that means that we want to start at we want to start at that's not quite right, but well, maybe it is. For 3 digits, it starts at 10 or 5 digits. I mean, it's actually right for whatever, but is it right for 2 digits though? Not this one. Oh, this is incorrect. Or maybe no, this is right. Why is this wrong? For even digits. Oh no, this is for 1. That's not an even digit. Okay, for n is equal to 1, then we have 1 digit, so we have left half. Okay. And then if n is odd, then we have so this is 0, but that's because n is equal to 1. Okay, well, if n is equal to 1, we just special case it, I think. I know I could write this in a better way, but I don't know, not doing that. Let's just say, okay, let's just say generate 2, and we have, whatever, it doesn't matter, I guess. Okay, the 2-digit ones are right, the 3 and 5 digits are right, so I think we're good on the generation. So these are all things, and then now it's just about f is equal to so we just have to Yeah, I mean, this is actually not that bad. I just kind of misread the problem. So then now we have n factorial. Okay, let's just write n factorial. N fact. Right. Or maybe we just have factorial in general. And then now we have, can we add factorial of n? No, not yet. So we want to say it's going to be this for x in f type values, current x, right? So count current, and then we have to subtract out the leading zeros. So if after f, oh no, not f, f of 0 is greater than 0, then we want to take out the ones where, okay, current is equal to fact of n minus 1, and then for and then we do f of 0 subtract from 1 for x in f values, current right, and then count subtract current. I should could have int not variable 22. Huh? Oh, this is an int. And also I reused the current, but okay, fine. 2 and 6 is, I don't know if this is right, but definitely the other ones are not right. Okay. Oh, it's not n factorial, is no, it should be. Oh, but do I double count on other? Is it distinct? No, because we're not doing distinct. We're not doing distinct because, okay, that's fine, maybe. Maybe we just have a, this is kind of crappy, but okay, we don't need the int part actually, because we can move back to that. And then now we have maybe, that's what, does that work? Okay, string doesn't have sort, so then maybe we have a, not sorts. Something like this, right? Okay, well. It's yucky. I thought that this would work actually, honestly, but okay, fine. Why? Zero, 1, 1. So we should have already done this one. Oh, this is actually not even right because we don't care about the mod. Larry, you have to think about the mod. Okay, fine. I forgot about the mod part. If int of current mod k is greater than 0, then, or not equal to 0, I can continue. 29, still overcounting, but maybe it's slightly better. I don't know. I misread this one so hard. Okay, so, well, that's the key. That's actually not quite right though, is it? print current key. Okay, so we have 50, but how what? Oh, because of this thing. Are we not subtracting correctly? Is that right? Yep, we're not subtracting correctly. This doesn't do anything. This is such a hack in general. But yeah, this is not doing anything. If f of 0, oh, it's f of 0, not f of 0, because I'm a lazy guy. Current x, so it's only for this one. So if this is such a hack now. That is actually surprising. In that, okay, I reused current too much, but okay, we just do a key. But okay, so that makes sense that it is 1. So okay, so 505 is good, but so 505, there's 3 combination, is that right? Yeah, it's 055, 505, and 550, right? Those are the 3 combinations. We subtract 1, so that's true. 555 being 2 is wrong, right? Oh, it's silly, Larry. Okay, now we have the right answer, but is it fast enough? Is it fast enough? Because we do a lot of funky things. So let's do, I don't know, 10, 1, I think is the worst case probably. It looks fast enough, and it's only 41 million. Let YOLO go. Hopefully no wrong answer. Okay. I misread that one so hard. Now, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.